Hey math students, we've been talking about a great topic. We're talking about sum of digits, divisibility rules or divisibility tricks. So divisibility tricks, I'll remind you guys, are those ways that we can, just by looking at a number or examining it, find out what it divides perfectly by. And as it turns out, that concept of divisibility plays its way into tons and tons and tons of math concepts that GED students struggle with, like reducing fractions, like adding and subtracting fractions, like factoring in algebra. All these skills have to do with divisibility, okay? So we're going to do sum of digits divisibility. Last video, we focused in on those threes. If you haven't checked that out, I'd go do that right now, because threes are the prerequisite skill now to talk about nines. So the first thing I'd like to point out to you is that 9 is a composite number. What do I mean by a composite number? This is another vocab word you have to know for the GED, but it means basically that I can build or compose 9 by multiplying together other numbers, smaller numbers. So I'm going to ignore like 1 times 9. That's not composing 9. That's already a 9. But for example, I could compose 9 by multiplying together 3 times 3. 9 is composed of threes multiplying together. And when I want to talk about a number being a composite number, I look at the prime numbers that it's composed of. Okay, now, that being said, we learned in the last video that the threes divisibility trick was a sum of digits trick. And so it should not surprise us, knowing that a 9 is made entirely of threes, 3 times 3, that it's going to have a similar trick. Let's write down the 9 times table in order to develop this. Now, I have had a lot of students who struggle memorizing their 9 times tables. If you guys know the finger trick, I love it. If you don't know the finger trick, it's amazing. You should look it up. But the finger trick is actually based on this sum of digits thing we're about to learn. That being said, I'm going to teach you a little different method than the finger method. I find this helpful for a lot of students if you don't know your 9 times tables. If you do, you can just fast forward past me saying this. But I just want to say this. Do you agree with me that 9 is 1 less than 10? You students are sometimes so stuck in their ways. They're like, there's only one right way to do things in math, and that is just simply not true. There's so many right ways to do things. As long as you're being logical, you really can't go wrong as long as you're using logic in math class. So 9 is 1 less than 10. What does that mean? That means that if I wanted to, instead of adding 9 each time repeatedly, I could add 10 to my number. So from 18, which is a 10 and an 8, I could go up to 20. I'm adding 10. But remember what we said. We said 9 is 1 less than 10. So instead of going all the way up to 28, like I would if I added 10, I'll go 1 less than that. I'll go to 27. Let's do that again. We're going to go up by 10, 10, 20, 30, and down by 1, 9, 8, 7, 6. Do you see it? Some people call this the elevator method. Up by 10, down by 1, up by 10, down by 1. Do you see how? Look at that tens column. I'm going from 0 to 1 to 2 to 3 tens, 4 tens, 5 tens, 6 tens, 3, and I can use this to continue to develop my 10 times table, or my 9 times table, sorry. Now, I just want to point out something to you guys, because a lot of people do the next one wrong. They're like, oh, up by 10, 9, from 9 to the next number in the tens column is going to put a 10 here. And I agree, but the problem is going down by 1. I can't go down by 1 into 0, because what am I going to get? -1, 10, -1? That doesn't make sense. But I can go down by 1 from 100, if you think about it. 1 less than 100 is 99. And so I'm always like, do whatever math is easier. I just think it's easier just to add 9 in this case. 90 plus 9 is 99. But after that, it will get easier again to do my 10-1 method. So I'm going to go up by 10 from here. So up from 9 to 10. I need more room. So that's 10 tens. I have 10 tens or 100. And then down by 1 from 9 to 8. And up by 10 to, I have 11 tens, 110. And down by 1 to 7. And so on and so forth. And using this method, I can count by 10 or by 9 for a really long time. Okay, now we said that the divisibility trick for 9's is what's known as a sum of digits trick. What does that mean? Sum means to add up, and digits mean the individual number symbols. And so that's what I'm going to do. I'm going to add up the individual number symbols within each number, add the digits. So in this case, there's only one digit, 9, there's nothing to add. But starting at 18, it's a 2-digit number. I could add the 2 digits together, and 1 plus 8 would give me 9. And a really strange thing is going to happen. No matter which one of these numbers on the 9 times tables that I add up here, I always get 9. 4 plus 5 is 9. 5 plus 4 is 9. 6 plus 3 is 9. And so on and so forth. Remember how I said that the finger trick is explained by this? If you know the finger trick, the one where you hold up all 10 fingers and then you put down one, like you hold up 10 fingers and then you count to 3, 1, 2, 3, you put down your third finger, and you see 2 fingers on the left-hand side and 7 fingers on the right-hand side, 27. I'll show you a picture of what I mean. Since I can't record I'm a math teacher, not an artist, y'all. But if I put down my second finger, I'd have 27 here. That's all based on the fact that since you have 10 fingers, if you put one down, 9 will remain standing. And my sum of digits always adds to 9. So it's a neat trick. Okay, but take a look at the next one. 9 plus 9. I got into some of these bigger digits, and it doesn't, as it turns out, even though the first 10 act like that, it doesn't always behave exactly like that. Because 9 plus 9 is 18. Now, you may be saying, Kate, you broke math. This doesn't work. But I would say to you it actually does. Let's think about the number 18. First of all, 18 is on the 9 times tables. But second of all, guys, 18 is still 2 digits. If you really want to get it all the way to 1 digits, you could just keep adding. Keep adding those numbers. 1 plus 8, what do you get? Oh, look, 9. And we can keep going like that. So let's go ahead and erase over here and take a look. No matter how many of these 9 times tables you do, if you sum the digits, you're always going to get to something on the 9 times tables. 1 plus 0 plus 8 is 9. 1 plus 1 plus 7 is 9. And 1 plus 2 plus 6 is 9. Wonderful, wonderful rule we can develop. Basically, if the sum of digits is divisible by 9, so is the number itself. If the sum of a number's digits is divisible by 9, so is the number. Very nice. So, that being said, let's apply this to some GED math problems. You may be asked, is 9 a factor of 5,733? Let's check it out. What I would do here is I would sum up the digits, since 9 has a sum of digits divisibility trick. Now, of course, I could go the long way. I could do long division. But I don't want to go the long way when I know a shortcut. 5 plus 7 is 12. 13, 14, 15, 16, 17, 18. I sum these up, I get 18. Is 18 on the 9 times tables? Of course it is. What if you don't know your 9 times tables? Try just adding 1 and 8. 1 plus 8, of course, gives me 9. And even if you don't know your 9 times tables, I bet you know 9's on the 9 times tables. So obviously, since the sum of digits is divisible by 9, this original number here, this number itself is divisible by 9. So the answer here is yes. Again, this could come up in different ways. You could see them talking about factors. You could see them talking about multiples. So how about is 23,077 divisible by 9? Oh, I meant to say a multiple of 9. Same difference, by the way. They mean the same thing. A multiple of 9. So again, I'm asking you if this number's on the 9 times tables. Obviously, I don't have my 9 times tables memorized up this high. I could just do the division and see if I get a remainder, but easier, I can do sum of digits. So let's see, 7 and 7 is 14, 15, 16, 17, 18, 19. I get 19. Is 19 on the 9 times tables? No, it's not. And if you can't tell, you could keep adding. 1 plus 9 is 10. Is 10 on the 9 times tables? Of course it's not. Answer to this is no. This again, this skill is going to come in so handy, so very, very handy when reducing fractions. Lots and lots and lots of times, students look at a problem, they panic, they have no idea how to reduce it. Taking a look at, like, for example, 54 over 81, a really quick sum of digits here would tell me that 5 plus 4 is 9. This number is divisible by 9. 8 plus 1 is also 9. That number is divisible by 9. Both 54 and 81 have a common factor of 9. I could divide it out of both of them. I'd get 6 over 9. Now that particular fraction would keep reducing. They do have a 3 in common I could keep reducing by. But knowing my sum of digits trick really made a big difference in reducing this fraction. All right. We are going to continue this topic of sum of digits trick with a quick look next video at the 6 times tables. 6 is also on the 3 times tables. 6 is composed of a 3. It has a 3 in it, and so you will see the sum of digits tricks show up for 6's as well. So stay tuned for that.